All right, so this is section 8.6. We're doing 8.6 and 8.7, solving equations with common logarithms and natural logarithms. First, we're starting off with common logarithms, which are base 10 logarithms. Those are the ones that are on your calculator. So common logarithms, base 10 logarithms, are called common logarithms. The expression log base 10 of x is usually written without the subscript as just log of x. Use the log key on your calculator to evaluate common logarithms. The relation between exponents and logarithms gives us the following identity. I explained to you that if you don't remember that this answer is x, it is because whenever you have a base raised to an exponent that is in this that is a logarithm in the same base of x, the answer would be x. Now you can rewrite this as a logarithm to figure it out. Log base 10 of something, which is x actually, equals the log of x, the exponent. So I rewrote it exponentially so you can see that it has to be x. You don't have to write that down if you understand it. The answer is x. All right, so we're going to evaluate log 50 to the nearest 10,000th. We're going to use the change of base formula. Okay, what that said was the log in base b of whatever, something, x, would equal the log of x divided by the log of b. All right, so you change it to base 10s, and then you can pop it in your calculator. So this would be the log of 18 divided by the log of 6. You cannot cancel out those logarithms and say 18 divided by 6 is 3. That does not work. You cannot type the log of just 18 divided by 6. That will not work either. You have to type exactly what you see there. So when you do that, you need to be very careful about parentheses if you're going to type it all at once. I tend to do this, log 18, enter, and then I hit divided by log 6, and then enter again. If you're going to type it all at once, I'm only going to do this one time, and then I'm not going to discuss you need to put in parentheses if you're going to do it all at once. So if you do log 18, close your parentheses, divided by log 6, then you would get the same answer. So it's 1.61. I believe we're going to the hundredths place. Yes, nearest hundredth. 1.61. Second one, you're going to do log 215 divided by log 10. Oh, by the way, did I need to rewrite that one? It's already base 10. Okay, so you could have typed log 215, but here's another reason why this is okay. The log of 10 is simply 1. It's 10 to what power is 10, so it's 1. All right, so anyway, log 215 is all you have to type. And you should have gotten 2.33. This one, you're going to type log 76 divided by log 2.5. And you guys go ahead and type those in, please, on your calculators. And what did you get for that one? Anyone? 4.73. I would practice typing these, making sure you remember what you're supposed to do. Log 329 divided by log of 1/16. Okay, you need a parentheses around that numerator. When I did this, I got negative 2.09. Any problem with that? Okay, I just don't need to keep dragging up that calculator and slowing us down. You're faster than me. Okay, now here's an example of how to solve for an exponent. You use logarithms. So what happened was 3 to the 2x plus 1. I can't change the base and then rewrite it, etc. I can't use methods that we've done before. When you can't use a method that you recognize from other times that we've discussed how to solve things, you're going to need to take the log of both sides. So what they did is they took the log of both sides, and then they used the power rule that we learned yesterday and put that exponent out front because of the power property. And then they said, okay, well, let's get this 2x plus 1 alone. And so they divided by the log of 3. Now this over here, log 12 divided by log of 3 is simply a number. So we're down to 2x plus 1 equals something. I'm just going to go on the calculator and type that part. So log of 12, close your parenthesis, divided by log of, was it 3? Okay, and then we'll write down this decimal, 2.262. Now let me explain something. I did go out 3 places, even though I think it's rounding to the nearest hundredth, because during the problem, I don't want to round until the very end. Okay, so I went 1 decimal place more than I maybe asked for. All right, then we're going to need to subtract 1. We'll have 1.262, and then we're going to have to divide by 2. And so we're going to get 0.63 for our final answer. If you went further, 0.631. It didn't really say, it did say the hundredths, so I guess 0.63 would be fine. All right, now let's do some of our own. I do not know what power of 7 is going to give me an 80, and so I use logarithms to figure it out. It's probably some weird decimal. Okay, so I take the log of both sides. Log of 7 to the x equals the log of 80. Then I use my power rule for logarithms, which says this is an exponent and so is a logarithm, so you can change to multiply. So x times the log of 7 equals the log of 80. Next, to solve for x, I'm going to divide by log of 7 on both sides. And then I'm going to type on my calculator to get my answer. Log 80 divided by log 7. And I get 2.25. I think the directions, let's see, said round to the nearest hundredth. So 2.25. The next one, I need to take the log of both sides. And that is 4 to the x plus 1 power. Okay, I can bring that exponent out front. So I've got x plus 1 times the log, or I'm going to put that in parentheses, maybe that'd be better, times the log of 4. And then, guys, maybe you realize the log of 100, you should know the answer to that. 10 to what power is 100? 2. Okay, so you could simplify that to 2. And then log of 4 is a number. I'm going to divide by it. X plus 1 equals 2 divided by the log of 4. And again, it wouldn't have mattered if you went ahead and didn't evaluate. If you type log of 100 divided by log of 4, it'd still be fine for solving the problem. Okay, so what's 2 divided by, or log of 100, or 2 divided by log 4? Okay, now what do we need to do next to get the x alone? Subtract 1. Okay, so it's 2.32. Now I transpose my numbers in my head. We got 3.32, and you're going to subtract 1, so x would equal 2.32. Okay, do you mind if I go ahead and put the exponent out front on the next one right away? If you don't understand what I'm doing, please tell me. So I'm going to do 4x minus 1 times the log of 3.6 equals the log of 85.4. So 4x minus 1 equals the log of 85.4 divided by the log of 3.6. So log 85.4, I'm going to clear this out. Log 85.4 parentheses divided by log of, was it 3.6? Makes it a little faster if I can verify that. Okay, look over my notes. I got 3.472. And then I'm going to add 1. And then divide by 4. I think it's 1.11, and then Oh, so that should round to 1.12. To the nearest hundredth. Okay, anybody need this page still? No? All right. Hopefully feeling all right. There is something missing, I believe. Yeah, I do not know why those are missing from my smart notebook, but let's do them. Number 8 is can I just take the log right away, log of both sides, please? So I'll put the exponent out front, x plus 5 times the log of 2 equals, bring the exponent out front, x minus 2 times the log of 3. That would be like my first step. Ooh, I got to get the logs on one side and the x's on another side, or away from them. So I'm going to divide by the log of 2 and divide by x minus 2. So that's going to be x plus 5 over x minus 2 equals the log of 3, and now I'm dividing by log of 2, divided by the log of 2. Now, remembering that this is just a number, okay, we can go ahead and evaluate log of 3 divided by log of 2. And that, I believe, okay, let me go back and look at my one. I already calculated it, 1.585. I'm going to go 3 places. Okay, now what could I do? Cross multiply, or you could just multiply. Yeah, well, basically, you're going to multiply across. Okay, so x plus 5, if I can get my pen to stay still, 1 times x plus 5 is equal to 1.585 times x, I'm distributing, please, minus 3. Oh, can somebody do that, please? 2 times 1.585, is it 3.9? No, 3 point what? 1. Thank you. Perfect. All right, now, I need my x's on one side, and I've got 1x on the left. So I'm going to subtract x and add 3.17 at the same time. So that's going to give me 8.17 equals 0.585x. Okay, I'm doing 2 algebra steps at a time here. And now I'm going to divide. So I'm going to do 8.17 divided by 0.585, and I'll finally know what x is. 8.17 divided by 0.585. And I think it was 13.97. I don't care how you write it, but there you go. Great. Number 9. 9 is 9 to the 3x equals 4 to the 5x plus 2. No way to get those into a common base. If I could, I would, but I can't, so I'd use logarithms to solve for the exponent. So I bring my exponent out front, 3x times the log of 9 equals 5x plus 2, parentheses, times the log of 4. Much like the last problem, I need to, and it really doesn't matter which side you do it to, but I'm going to get my x's on the left, so I'm going to do 3x over 5x plus 2, dividing by 5x plus 2 on both sides, and at the same time divide by the log of 9 on both sides. Evaluate this log of 4 divided by the log of 9. Now, I could have distributed this number, but I just don't see it as being any easier to do, so I'm going to do it like this. What is log 4 divided by log 9? Okay, let me see if I get log of 4 divided by log of 9. 0.6309. Okay. All right, now I'm going to do cross products. I'll have 3x equals 5 times 0.6309. What's that? 3.15 and then 4? Okay. Or is it 5.5, I think? Okay, 5.5. And then plus, oh, that's got an X on it. Plus 2 times that would be 1.262. 1.262, right? Okay. Now, all I need to do is, oh, I think this one, I got to subtract 3x from both sides, but then I've also got this number here, so I can just subtract the 3.155x. It's going to be negative 0.155x equals 1.262, and then I'll have to divide by that. All right, so grabbing your calculator, 1.262 divided by, what was it? I didn't do it the same way when I did it on my notes. So could you guys just tell me so I don't have to look back? Negative. Oh, I can't put the negative sign there, dummy. I'm talking to myself. Negative 0.155. Is that it? Okay. Did you guys get negative 8.14? Okay. Okay, just so you know, I actually bad teacher. I don't know what's happening with my. Okay, on the back on 17b is all we're doing is the same stuff now, except we're doing the natural base of e, the natural logarithm. Okay, so when using the inverse functions f of x equals e to x and g of x equals the natural log of x to solve equations, natural log of e is the base e logarithm of x. Therefore, the natural log of e is 1. So it's nice to know that natural log of e is 1. Why is it 1? Because it means e to what power equals e, which would be 1. Okay? That's why. Just like the log of 10 in base 10 is 1 also. So to simplify each expression, this would be 4. Do you guys understand why it's 4? All right, that's e to the natural log in base e of 4. It's just like the one we went over on the other page for logarithms. So since these match, the answer is right there. Again, another way to think about it is, if you were to write this as a logarithm, you'd do the natural log in the base e of something equals the natural log in base e of 4. What has to go in the blank? 4. That's why the answer is 4. Okay, so this one, we need to put the 2 back on the 3 as an exponent. So this would be e to the natural log of 3 squared. So the answer to this one is 3 squared, which is 9. Okay, this one, the base is e. So e to what power equals e to the 9th? Well, this one is also 9. The answer is the exponent. And this one would be 5 times, what's the natural log of e to the 3rd? Well, it's the exponent, which is 3. Or you could have done, this one could be done a bunch of ways. If I put the 3 back out front, it would be 3 times 5 times the natural log of e. The natural log of e is 1, so this would be 15, just like this is 15. So you could have thought of it more than one way. Okay? Get 15 no matter what. You could have also put the 5 back on here. Do you see how no matter what I do, it's going to be 15? All right. Write an equivalent exponential or logarithmic equation. This one is exponential. So we're going to write the log. You know the base is e. Oh, no. Why did I do log? Well, you could, but if it's e, let's use ln instead. And it's shorter to write even because it's 2 letters instead of 3 letters. How lazy is that? So ln base e of 3 equals x. All right, this one we're going to rewrite exponentially. E to the x equals 15. Base is e. E to the 0.6931 equals x. And this one is exponential, so we're going to write it logarithmic. The log, oh, I did it again. Don't want log, I'm going to write ln. ln of, which is base e, of x minus 3, and that should go in parentheses, is equal to the exponent 4. Did I go too fast? Are we okay? Good? All right, moving on. Now we're going to write each as a single logarithm. So we're applying those properties we used yesterday. They all go the same way with logarithms. So if you have a subtract, what are you going to do? Write a division. All right, a little reminder. All right, so the natural log, of course, is in base c of u times, say, I don't care what these things are, x. If you have a mole product, you can write that as the natural log of u plus the natural log of x, and that e doesn't have to be written, okay? So this is just the product property. All of the properties we talked about yesterday for logarithms apply to natural logarithms as well. So if you have the ln of x divided by y, that would be the ln of x minus the ln of y, okay? And the natural log of x to the n would be n times the ln of x. That's the power property. All right, so we're going to use those properties on these. Put the 3 back on as an exponent and the 9 back on. So I have the natural log of 3 to the 3rd minus the natural log of 9 to the 9th. Okay, I'm going to condense it now because it says subtract. I'm going to write it as division. Natural log of 3 to the 3rd divided by the 9 to the 9th. Now, I could go further with simplifying this. Since I can write 9 as a power of 3, that would be 3 squared to the 9th. You could actually simplify this a little more. That'd be, and you don't, I really was just looking for this, but I just see that a lot of you guys would probably think, well, I could go down further with that. So that's why I'm showing it. Because these are ginormous numbers. If you put that on your calculator, we do not want to write that number down. So I'm working with the base, the powers. So that's 3 to the 3rd over 3 to the 18th. So what could I do next? Just to simplify it one more time. What's 3 to the 3rd divided by 3 to the 18th? 1 over 3 to the 15th, guys. The bases match, you subtract the exponents. Okay. Okay, you know, that is humongous, that number right there. I'm not bothering to write it down, but okay. Make sure you can get to here at least, but we should be able to get to that. All right, 10, put these back on as exponents. So I'll have the natural log of x squared plus the natural log of 4 squared. If it's an addition, we rewrite it as one logarithm by multiplying, and 4 squared 16, so it would be the natural log of 16x squared. And these are in parentheses. We okay? All right, solve each equation by for x by using natural logarithmic function. Round the answers to the nearest 10,000th. We're going to go 4 decimal places on these. We want to find the exponent on e that would give you a 34, or there approximately, since we'll be doing some rounding. So to solve for the exponent, we take the natural log of both sides since it's in base e. So we have the natural log of e to the x equals the natural log of 34. Step 1. Step 2, use the power property of logarithms to bring x out front times the natural log of e equals the natural log of 34. Okay, what's the natural log of e equal? We want to remember that. So that's just 1. It saves us a little effort in calculation. So x is just whatever the natural log of 34 is. And you can type that, of course, on your calculator. So you have your ln button, so we're down here. Natural log 34. It was 34, right? I don't know what. 3.5264. to the nearest 10,000. That's really bright. Okay? Any problem with getting that number on your calculator? You guys should be practicing. Cameron. Hello? Good? Practice, guys. You better be typing the buttons. It really helps you learn it. All right, what do we need to do here? What should I do first? Did you? Were you doing it? I thought you were. I don't want to say anything. All right. What can I do to this one? Your head was down, so I thought something else. What can I do to get this started? What would be the best way to start the problem? What's that? Addison, what are you going to do first? Yes, you are. Okay, now you're going to take the natural log and bring that exponent out front. X times natural log of E equals natural log of 40. Are you okay that I didn't write a step between here? I went jump to the exponent coming out front. Okay, natural log of E is 1. Yay. So all you have to do is type in natural log of 40 on your calculator and you will be done. As long as you round correctly out to the nearest 10,000. 3.6889. All right. Number 13. Solve each equation. Same thing. 4 places. Oh. Can't take the natural log of the natural log. I already got a natural log in the beginning, so I can't do what I was just doing. When you can't do what you thought you were going to do, what should you try to do? When it's not like the other. Anytime you look at a problem and you're not, and it's got a logarithm in it, and there's not logarithms on both sides or natural logarithms on both sides, you need to rewrite it as an exponential equation. Okay? So what's the base? E. So e to the exponent 2.8 is equal to 3x minus 2. Oh, this is really easy now because all I have to do is type in e to the 2.8 and then I'm going to add 2. So I'm going to get that in the calculator and then I'm going to divide by 3. So you could type this, e to the 2.8 plus 2 divided by 3. Be careful if you type that. I would do second, bless you, natural log 2.8. Okay, then I would error out of there. I can add on the 2 right now, but after I do that, I can't hit divided by 3. If you do, it's going to come out wrong. Okay, you need to hit enter and then hit divided by 3. Otherwise, you will have told it to divide only the 2 by 3, and that would give you an incorrect solution. So this is 6.1482. Okay. Next one, I'm going to get that e to the 2x all by himself before I do anything. So 3e to the 2x, subtract 2 from both sides to get 8. Divide by 3, just leave it as a fraction, 8/3. Now I'm going to take the natural log of both sides, and I'm going to bring the 2x exponent out front. 2x times the natural log of e equals the natural log of 8/3. Okay, natural log of e is 1. So all I have to do to get x is figure out what the natural log of 8/3 is and then divide it by 2. Natural log of 8 divided by 3. I like to hit enter now. And then I'm dividing that by, was it 2? Okay, and I get 0.4904. All right. 15. isolate the natural logarithm, I would add 5 to begin the problem. Negative 2 plus 5 is 3. Now I'm back to something that looks a lot like the previous problem. So what should I do? What's the base? And then I'm going to rewrite it as an exponential function. So e to the third, equals x plus 3. So this one's again now easy because all we have to do is type e to the third minus 3 and we have our answer. Is anybody not sure how I'm putting in this exponent without using the arrow up key? I'm using ln, what's above the natural log, which is e to the x. To put, that's an easier one to use than the one above the division. Okay. I think I subtracted the wrong amount. I need to subtract 2 more, right? It was subtract 3. Should be 17.0855. And then 16, I need to condense this into one logarithm before I start the problem. So I'm going to use the product property that since logarithms are exponents, when you add the exponents, that's when you multiply. So to rewrite this, we'll do the natural log of x times 2x equals 2. I'll simplify x times 2x to 2x squared. And then now that I'm here, I need to write it as an exponential. The base, of course, is e. The power is 2. That equals 2x squared. And then we'll need to divide e to the second by 2. And then lastly, we will take the square root and omit the negative solution as it would not work in the original problem. Can't take the natural log of a negative number. So I'm just going to type it just like that. Second square root of e to the second get out of that exponent. What was I dividing by? 2? I think that should work. Yep, 1.9221. And one more. Or no, is that the last one? That was the last one of those except for now revisiting the PERT formula. The amount is in the account is the principal times e to the r rate times time exponent. So find the amount using the PERT formula for continuous compounding of interest. Okay, so the amount in the account. Oh, that does not show up. Red on red does not work. Okay, so A would equal P would be my 1,000 times e to the rate 0.04 times time 10 years. This is all calculator exercise. Oh, I did. It was only 1,000, right? 1,000 times e. Oh, I can't. I'm a blindness. Oh my goodness. All right, you guys are probably done getting that one. I don't know what I just did to my calculator, but I'm going to say that if you already got, and so I can save time, if you already got $1,491.82, we're ready for the next question. All right, the amount for the next one would be 800 times e to the 0.07 times 3. All right, I'm going to let you guys calculate these. Because this is simply pushing buttons. Okay, if anybody had a problem with calculating these, just let me know. You should have $986.94 for the second one, and number 19, $3,415.39. Anybody need help or want me to type this on my calculator? All right, how long will it take to double your money if you deposit $1,200 at an annual rate of 6.9% compounded continuously? Okay, it's compounded continuously, so we know we are using the amount in your account is equal to P times E to the RT. How much are you going to have in your account if your money doubles? 2,400? Okay, that's going to equal 1,200, the principal, times E to the rate of 0.069, and you need to know T, the time. We are no longer going to use the graphing calculator for this problem. We're going to solve it using logarithms. Oh, this is totally wrong. I did not write that. I don't know. That's not even the right formula. Unlock and go away. Sorry, wrong one. Do you see what was wrong with it? It said P equals. No, that's not right. Okay. So if we divide by 1,200, that's what I would do first. Guess what you could have put in here instead? 2. Doubling. Right? Doubling, doesn't matter what the amount is, it's doubling. All right, now to solve it, we would take the natural log of both sides. The natural log of 2 equals the natural log of e to the 0.069t. Now, if you wanted, bring out the exponent right away. Natural log of 2 is equal to 0.069t times the natural log of e. And we learned today, or got reminded today, that the natural log of e would simply be 1. Okay, so all we have to do is take the natural log of 2 and divide it by 0.069, and we will get the time it takes to double. Natural log of, was it 2? And then divided by 0.069. And I got 10 years. You can drop off that decimal part. Okay, so that'd be about 10 years. How long will it take to triple your money? So what are we going to put instead of tripling some $2,000? You could put in the 6,000 equals 2,000 times e to the 0.085t, bless you. Or you could just simply say, well, if I'm going to divide by 2,000, I'm going to get 3. And then I'm going to take the natural log of 3, or of both sides. I'm going to bring the 0.085t out in front of my natural log of e. Natural log of e is 1, so I'm just going to do the natural log of e. Natural log of 3 divided by 0.085. And that's about 13 years. Okay. That is the end of the lesson, which I will give you those assignments to your quiz preview and worksheet 16 for practice for tomorrow's quiz. Not tomorrow's quiz, next day.